Hi, this is the second issue of this Raku challenges overview. So let's go back to challenge number 69. And the second task here is to generate some strings, 0/1 strings. Actually, it's a string in which each character is either 0 or 1. Write a script to perform switch and reverse to generate S30 as described below. Every 0 becomes 1 and every 1 becomes 0. For example, 101 becomes 0, 1, 0. This is the switch function, and the reverse function, the string is reversed. For example, 001 becomes 100, yeah. And here is the explanation. So the first string, the 0th string is empty. Then we have 0, and the nth string is the previous string plus some character plus 0 plus switch reverse the previous string. Looks like everything is clean, with the only exception that it was originally asked to generate the 1000th number in this sequence, but that's actually impossible because there are like too many numbers in this string. Okay, so let's look at the solutions. So we have to go to recap. Where is recap? Here is recap. And we are looking at the solutions in the Raku programming language. Let's start today from the very beginning in Raku solution. Okay, I will not start with mine. I will start with Lukas' solution, Raku number 2. Let's see what's there. Okay, so the program which have this switch function and reverse function explicitly defined, and here like maximum defined, optional with the default value of 100. 100 is a bit too much, I believe. Current string, and we are trying to basically generate the string according to the definition. If the current number is what? So this is for the first two. So this loop goes over all those hundreds or whatever numbers, and these two lines are only for generating the first two items in this sequence. Next, if it is 0 or 1, to skip this. Okay, so these three lines work together. Very interesting. Then current string is current string plus, well, concatenated with the 0 and with the switch reverse of the current string. And here current is actually the previous version, right? In the switch function, we have this function. By the way, notice that there is the where clause, which contains a regular expression, and it looks like it's a bit optional. It's redundant here because, first of all, there's only one version of each of these functions, both switch and reverse, and second, well, there's no other strings which will not pass this condition. But nevertheless, so what it does, so it has the bits, definitely bits array is just a regular array. It's not like binary array. String split, we saw this last time, split into characters, and edit push 0 to this array if the digit is 1 and vice versa. And as soon as we see 1, we can break the loop, then we join it to get a string, and then we return it here and concatenate, and finally in the main function we print csay. What is csay? I believe this is a typo, right? There's no csay method as far as I know this. Let's go to the solution, cd Luka. Hey, where am I? I'm not here. Cd Luka Ferrari Raku second solution. I believe I need something smaller, right? Yeah, there's no ding ding. Let's do, where is it? Here it is, right? Yes, it generates some number, and I assume it is correct. Okay, fine. Let's go to another solution by Mark Anderson. Yes, this is the solution I like. So what it does, it just, this is, unlike the previous solution, the augmenting operator, how they call it in Python, augmenting operator is used, so we just modify the string and we do it like this. Yeah, it's always like, sometimes you have to think that which value you have here when you're trying to modify the same string. But yeah, translation for the first and third number, and after that we can just print. So this one will work. I think it will work a bit longer than I want for the demonstration. Who was that? Was Mark. We know that there are more than one Mark. Raku, CD Raku, Chi 2. Yeah, definitely. I want, I believe, like 5 again, or maybe 6. Right. Yes. Okay. Something is printed. I will not check if it's correct or not. I believe it is correct, because the first string is an empty string. That's right. Going next. Next is Shahid Raku number 2. Wow. Yeah, but we don't have a sequence here. Notice that these quotes are like regular typographical quotes. It's not like the ASCII characters, but it should work in Raku because it accepts the Unicode characters, including this one, for example, 3 dots. But we need to Raku. If I will type this, I will not get the desired results, or this slash is my for example, I need to do it like this, right? 6. No such method flip. No, I believe this is for invoke capture. Oh my god. So what? So this is a sequence, right? This is a sequence. Equals right. Say for S like 6. Okay, so the first string is empty. This is it. Then it's 0, because this is 0, and yeah, it's a number, but here it is a string. Then all the rest. Okay, nice, really nice, especially these quotes. Arna Raku 2. Okay, so here is the output. Again, we see that unit sub, so all these lines belong to the main function with some default value, 30. We don't need it that much because it will be really slow to generate 1 gigabyte of zeros and ones. So there's the switch function, which is just the definition, but unlike the previous solution, for example, the map function, the map method is used here instead of trans. String 01 is, wow, it's a boundary. It's a binding operator. Wow. Gather and take. There's only one take inside this gather. It can be replaced with array push, for example, but yeah, gather take is really good as well. And the previous one, which is originally an empty string, then this obvious thing, and again the quotes, the typographical quotes. Finally, we want to print everything, so yeah, we will get the block inside this string, and this block is interpolated, and it will just print this one. So, and this one is actually the gather block, which will be kind of inside of this, so we will get lazy computation, I believe. So we should see the result even without modifying the program. Let's see, it's interesting. Arne Raku second solution. Yeah, how can we see it? Yes, empty string, and the quotes come from here. Yeah, nice, really nice. The nicest thing here is that this binding is used to bind a variable to a gather block, which generates a sequence, and then we use this as an array. Nice, interesting. I wouldn't think of this solution. Yes, now we, Athanasius, I think we will see something big. So the comment, yes, this is what I just said, that the S30 is 1 gig of numbers. It's too many, and here is an example of the generated S11. It's really amazing how quickly it grows. And the whole solution, wow, yeah, so this program is actually short, and it does basically this for max s. What is max s? Is 11. It's a constant, my unsigned integer constant, max s number, and we just print it. Actually, say can be used here as well. Again, the augmenting concatenation 0 plus switched version of the flipped version. And the switch function is just tr. We saw it yesterday. Tr, the capital Tr, is the replacement which does not change the original string. We don't have an original string here, but the original string is here, and the with thing is used. Wow, I've never seen this before. So what is with? It's a kind of if and given combined together. But yeah, I believe we can check it. What is with exactly? With no, with where is control flow? With, yeah. So the with statement is like if, but tests for definedness rather than truth, and it topicalizes on the condition, much like given. So this is what we can do with this. Let's try this. With Raku. So for example, I have my variable being ABC, and I can with S say okay, right, Raku with okay, and if it's empty, it still will print okay, but if it's undefined, then it's not printed, right? But the thing is that I can also use this as a thing that sets a topic variable, so I can just call a method on it, right? Here I will also see this, but you see the empty line, that's correct. Right, can I use it like this? Right, and like this, it will be an empty string, and it's, yeah, interesting. So basically, with can be used instead of say if defined blah blah. Okay, nice, interesting feature which you can use. And notice also that there are two more, or with and without. Yes, Colin Crane, Raku number 2. Some explanation. The task. Right, wow, and the program is really short, so it's printing s of n and the function s. Why this space here? If n is 0, or not defined actually, then returns this empty string, then the previous string combined with the translated and flipped version. Yeah, and notice that there's no return function, the return keyword at the end, because this will be the return value. I believe this will work without any problems. The only thing that I want to change the n here with the S30. Who was that? Colin Raku second like 5 or 6. Right. Okay, this is easy. Rosenfield. Yeah, so we have the switch function as a separate function, which, haha, interesting, it takes a string called number, Polish notation in action, then we split into characters and we replace every character to flip the bit, and then we concatenate. So here is the list of characters, and here we get a string. Nice use of this concatenation operator inside the reduction meta operator. The previous string, so he started with the S, what is it, 2 or 3, and then for some more numbers, it's a simple switch, and notice that there are no parentheses around the function call, around the arguments of the function call, and we just say the number and the result. Raku second. Right. Okay. Going next, Mohammed. Let's take his solution now. What we see here is you need to enter the command line argument containing the S, so something like S5, and this is a string where, see, the colon indicates that it's a named parameter, and the string is basically, wait, yeah, so it's S, but it's case insensitive, so it can be S capital or S not capital, and then you just string 0, you call this function and print the result. And the function, what it does, so it, interesting. So it makes the regexp matching. Then for each of these, basically there's only one, you call int, and you then assign the result. An interesting pattern, I would say. I didn't use this. The problem, okay, so regex Raku, let's call it like this. So you have this string, say S5, right? And I want to extract 5 and make it an integer. Well, it will be an integer. Raku regex. Sorry, string, there's no string. Of course there's no string. Yeah, well, basically don't need this, like you can do it like this, but it is a string already. I wonder what even more interesting we can do out of this, but I don't know. But the problem here is that, for example, if you will do it like this and say this, it will not be a number, and I cannot, for example, say it like this, right? Because in this case the limit, and I always suffer from this, because here to get the limit I have to do something like this. After that I can print limit, and it's still the match, so I can do it like this or like this, then it's fine. But if I do it like this, then yeah, interesting approach. Okay, probably we can use the given here because there's only one element here by definition, because we ask one. Okay, if it's something different, S30, yeah, well, yeah, we cannot generate more. We start with an empty string and we go up to limit, and there's this helper string which is a flipped, then we transliterate the digits, then we append something, and then we append the previous string and return this one. Yeah, so yeah, it's a straightforward definition which we can test. Mohammed Raku second, yes, yeah, Why is it? Because it's 5. If I will say 7, it should be like this. Right, interesting. Especially this one. This one. Roger Bell West, Raku number 2. Yes, this is a bit more cryptic, but we can decipher this. So here's the number, here's the length, I believe, number of characters. Here's where the exponentiation comes. Position, sequence, while, so infinite loop. We can break it with this. So this is sec. What is sec? 4. Okay, now here it's 3. Minimum of these two numbers. Then we generate some zeros. Why do we do that? Okay, then we append it. So wow. So we append this. We print some zeros. Why do we need this? So it's for 30. Then we increment and then print 1. So it looks like it's and the sequence. And what do we print in the end? So we print this 0 and then we print this 1. And then we, wow, I wonder if it works much faster than the previous solution than any previous solution with explicit string concatenations. Next sequence. So again, an infinite loop. Wow, I don't understand how that works, but I believe it works. Truncate. Wow. What does truncate do? Well, obviously it truncates, but what? No, I believe I did it incorrectly. Truncate. Yes. So truncate removes the fractional part of both real and imaginary parts of the number. Yes. Okay, but why the imaginary part here? Okay. So it's kind of. Oh my god, no, I will not understand this that quickly. But let's just run it. Roger Raku second. Whoop. Yeah, I see. So it generates the number immediately, which is really, really interesting. I like this. I like this because the program just starts immediately. For example, if we will replace it with 7, right? Yeah, so we get, but I really liked how it generated the result for big S. Right, okay, so going next, Ulrich, number 2. No syntax highlighting from the GitHub side, but the function starts here. So current is 0, so we start with actually with the first, not with the zeros number. Then we just print the last one, and the current is just my switch, which is this function. Yeah, we saw something before in a slightly different variation, and the signature is also interesting. So this function takes a string, and we define this as a copy, so we can modify this. Why do we need this? Probably we don't even need it, right? Because we map something which we get after this splitting into characters, so we don't modify the original string. And then we return a string, right? Current. I believe I don't want to wait until this is done, but let's just run it. Or here Raku, to Raku Here we will limit ourselves with something smaller, and we get the result. Definitely it's not 30s, but yeah. And this one should be the same as this one, right? Yes, nice. But my favorite solution so far is this one. It really, I don't understand how it works, but the thing is that it generates the string straight away without conceiving anything. And finally, is it all? Raku, wow, yeah. And finally, let's go to my solution. I believe you will recognize some parts of it already, so I'm just doing it like this. So for the first 9 numbers, I will print the number and the string in this sequence, and I have this definition of the task, where I use multifunctions to define the first elements in the sequence and the arbitrary number here. So the previous is obviously the previous one is, I'm just calling the function. It may be dispatched to the same function or to one of these two, and I will return, there's no return keyword here, again return the string according to the definition. This is really a time-consuming approach, but it works. Right, so it works. That's it, I believe, from the Raku side. There's one solution in C++ that I submitted, but I won't show it here. You can look it somewhere separately in the repository, but I believe we covered everything from this week. That was great. That was really interesting. Again, my favorite solution is the solution which generates the number straight away. How it works, yeah, it's your homework to understand how it works, especially things like this or this. Why we, like this, why we do need to print some number of zeros, I don't know, but it's really amazing how it works. And that's it. So thank you very much. See you next time, probably next week.